All righty. Can everyone hear me okay?
Yeah, we can hear you.
Beautiful. Thank you. Okay, let me get everything set up here. All right, guys. Well, welcome to Geology 105. Thank you all for being here. Um, Thank you all for being flexible with the schedule and being able to join through Zoom. We'll keep an eye on what the university wants to do as they kind of gauge how the Omicron variant is going to affect life on campus in the next few weeks. So we'll see if we continue through Zoom or if we'll be able to come back to class on next Monday, the following week. But luckily for us, this is a pretty easy class to translate online. And if we do have to go online, that should be a pretty easy switch and it shouldn't be a problem. All right, so let's get started. So just to let you guys know a little bit about me, my name is Mike Powers. I'm a PhD student here in the Department of Geology. I do research on glacial geomorphology, which is just studying glaciers and ice and how it interacts with the landscapes in which they're found. I do a lot of my research in the high dry Andes in Chile and Argentina. So I study ice, spend a lot of time in the mountains. That's pretty much all about me. Hopefully I'll be able to meet you guys soon and get to know you guys over the course of this short semester. But just to reiterate a little bit of information about this class, we do meet every day during the weekday, 10 to 11:45 a.m. My email is right here listed, mcpowers@udel. I have an office in Penny 204, so if we do end up going back in person, I'll usually be found there. So I'll definitely hold office hours from 4 to 5, which I'll also, for this week, I'll hold over Zoom. So I'll send out a Zoom link to everyone for joining those office hours. So also, if you do need any other time, if 4 to 5 on Tuesday and Wednesday doesn't work for you, just shoot me an email and I'll be able to figure that out. So no pressure. This is our textbook. It's Natural Hazards by Keller and DeVicchio. We'll be using that for reading assessments, which reading assessments should be online right now and open. So if you want to blitz right through them over the weekend, you can, or if you want to do it week by week, they all have different due dates and that's listed on the Canvas website. So this is what our Canvas site looks like. And since we're going to be mostly online, we're going to be doing a lot of stuff online through Canvas. So most of it is organized in modules. So for start, on the left, you'll see modules. Just click on that. You should be able to access it. If you can't access it, please let me know. If you're having trouble, if you're not seeing something that's supposed to be there, let me know immediately and I'll do my best to fix it. The way the modules are set up is that you have to complete everything in the prior module before you can move on to the next one. So the first one is just a brief orientation on Canvas, just in case any of you, this is your first semester and you haven't been acquainted with Canvas yet. So we'll be able to, it'll be a nice introduction on how that works. You'll see here it has a syllabus quiz. I do not have a syllabus quiz. That was the last semester. I just feel like that would be an insult to your intelligence. You guys are all in college, so you should be able to read the syllabus and understand that it's all the information you need is in there. So we won't be doing that. The way lecture will usually work, I'll start at 10:05, just to give anyone that has some technical difficulties that signs on at 10 enough time to work out any difficulties they have, just so they can listen in. We'll probably have a break around 11 or 10:45, just to give everyone a chance to get some water, go to the bathroom, do anything they need to do. An hour and 45 minutes is a long time to just sit in front of the computer, so I want to give you guys a break. So we will be taking a form of attendance, but it will be more based on participation than your actual attendance. If you all will be signed in, so I won't be taking attendance at the beginning of class. I feel like that's a little bit of a waste of time, but as long as you're able to get the work done, it should be fine. What I'll be doing is I'm recording this Zoom session, and any Zoom sessions we do have, I'll record and post those online for if any of you can't make class that one day, you'll be able to access that Zoom recording. You'll be able to listen to the lecture and work at your own pace. That'll be uploaded after each class, and I'll also upload the corresponding slides with that. And that'll be under media. The recordings will be under the media gallery under files on the Canvas site. And I'll also have a lecture slides folder under the files portion as well. So something we will be doing is using Poll Everywhere for your participation grade. Basically, I'll post a question on the slide, you sign in through it, and then you answer that question, and it'll record your response. I am new to using this, so we're not going to do it today, or probably not this week. I'm going to be using polls through Zoom, which I'm a little more familiar with. So we're going to be learning how this works together, because I've never used that before, but it should be interesting. So I'll start with a poll here. So have any of you personally experienced any geohazards? It could be flooding, volcanic eruption, tsunami, landslide, or an earthquake. Have any of you done that? So that poll is open on Zoom.
A few.
Yeah.
All right, a lot of earthquakes, a lot of flooding. Someone's experienced volcanic eruption. Who is that? No one wants to speak up on that one? All right, how about the rest of you? Would anyone like to share their experience? If you were caught in a flood or felt an earthquake, explain what you felt and when it happened.
I know for me, I'm from Jersey, so it was like a while back ago when Hurricane Sandy hit. There was a lot of flooding in my area, and it knocked out all the power, the heat, and stuff like that. So we were like stuck in the house for like 2 weeks without energy.
Wow, holy cow.
Yeah, it was bad.
Well, I'm glad you made it out of there. Yeah, Hurricane Sandy was a bad one, really bad one, especially for Jersey. Anyone else?
I'm from California, so I've been through a couple earthquakes.
Oh,
Nothing,
I bet.
nothing super major, but I remember over the pandemic, I was living on my own in like a newly built apartment building, and like there's a couple earthquakes where I could like feel the entire sort of foundation of the building move a little bit. It's pretty scary.
Wow. Was it Northern Cali, Southern Cali?
NorCal, San Francisco
North,
is where I'm
North
from.
Cal, San Francisco. Yeah, they get a lot too.
Yeah.
Wow. Thank you guys for sharing. Appreciate it. Anyone else before I move on? All right, from Jane, hurricanes hit your town a lot. Oh yeah, I bet. Kayaking down the streets. Wow, awesome. All right. Well, if any of you are from the East Coast and have lived on the East Coast for a while, the only one I can remember, the only earthquake I can remember is from 2011 that hit Virginia. It was a 5.8. I remember I was working as a lifeguard at the time, and I was sitting on my chair, and I thought it wasn't a big earthquake in terms of what you would experience in Cali, but it was enough that I could feel my chair shaking. I thought some kid was just messing with me, but turns out it was an earthquake from this large fault structure that's or a relic fault structure that's in Virginia. So I'm sure a lot of you that have been on the East Coast may have felt that one and remember that one because it was a pretty big deal over here. Not a lot of damage, no real damage at all, but it was interesting to have an earthquake on the East Coast. So yeah, thank you guys for your responses. Okay. Let's see here. All right. So just to reiterate about assessments, there'll be 10 chapters, so you'll have 10 assessments, and most of those should correspond with your lab assignments as well, even though that's a separate class. All of them, as I said before, all of them are available on Canvas, but they're due around the time that we finish a module. All the due dates are in the syllabus, and you can also see them on the Canvas site. Online quizzes, we'll have 6 quizzes. They're all on the Canvas site as well. They're open for 2 days right before they're due. So you have 2 days until you have 2 days to take it. You have 3 attempts per quiz, and your highest score is recorded. Make sure to keep a close eye on the due date. Make sure you don't miss it. But if something does come up, I'll be lenient and I'll be able to help you out. But just be proactive and plan ahead. We have 2 quizzes per exam, so we have 3 exams total for this session. And each of those quizzes, the questions on that will probably help you on your exam. So we'll also have in-class projects, which before this was supposed to go online, this would have been a lot easier to do in person because you could work in groups a little easier. So we're going to hold off on doing that this week. I don't think I'm going to have an in-class project this week, but we'll keep an eye on it. If we do end up going remote for the full session, I'll be able to work something out. So each of those they're due within 48 hours of the actual assignment, but your lowest score is dropped out of those 5. So if you miss one, you can just drop that score and then you'll have the 4 that you've done. Or if you do all 5, your lowest score is dropped and that brings your grade point average up. So these are the exam dates. These are not set in stone, but they're getting set in stone, all dependent on weather. But if we're remote, this wouldn't matter. So these are going to be administered in person. They're planned to at the moment. If we do go remote, we'll change it and we'll work out assigning exams through ProctorU, which I'll be able to figure out later this week. But these are your exam dates so far. So put that in your calendar. These are also on the syllabus. This is the breakdown of what your grade is going to be made up of in this course. So we have your Poll Everywhere polls, that's your participation grade, your in-class projects, your quizzes, and your reading assessments. So reading assessments are a big portion of your grade, a quarter of the grade. So make sure to pay attention to the due dates on those. And it really helps if you read the duly assigned reading. It'll help you on your quizzes and it'll definitely help you on your exams. So keep an eye on that. There are probably a lot of you taking Geology 115, which is the lab portion. If you're not, that's fine. If you are, keep in mind, we're gonna have, if you're in the Monday, Wednesday lab, your first lab is gonna be on Wednesday. Tuesday, Thursday lab, your first lab is gonna be on Thursday. There's just not gonna be enough lab material for you to talk about on Monday or Tuesday. So keep that in mind. Most of you should have the TA, Luis Del Cueto, who's a good friend of mine. Please stay in contact with him. And also, if you have any problems, let me know. And Luis and I can work out any issues we have with working on labs online or in person. So any questions that you have directly about lab, make sure to email him. Actually, just a quick question. Is anyone here in the Tuesday, Thursday lab?
No, I'm not, but I just had a question regarding the lab while you're on the topic of it.
Sure.
My professor hasn't posted anything on campus yet, and I know that we moved all online for the first week. So does that mean that we don't have a lab? Like, would you have any idea?
I know you're not going to have a lab this Monday or Tuesday.
Okay.
What we'll do is usually there's a pre-lab quiz that's due before lab starts.
Okay.
And then you have your lab assignment that you do in lab. What will probably happen is if there's nothing on, which section is that you're in?
1 second. Let me just go back to 115 to section 10.
Section 10. Okay, thank you. Yeah, I'll get back to you on that just to make sure that the Canvas site is up, because usually the university sets up the site for us and then we fill in all our information and all our assignments. So if nothing is on the Canvas site yet, we'll have to figure out what's going on there. Does it say who your TA is?
No, it just says I have the class with Del Cueto, but it also says on Canvas that the Canvas site for that class for the lab is not published yet as well. So
okay, all right. Well, I'll talk to Lewis about that and make sure that gets up. Thank you for bringing that to my attention.
Yeah, of course.
All right. Any other quick questions about 115 before we move on? Okay. All righty. So moving on to like the actual topics of this course. What is a natural hazard? A natural hazard is a natural process that is a potential threat to human life or property. As you can imagine, there are a lot of natural hazards that happen without threatening human life. We don't really care about those. Well, in a scientific sense, we do, but we care a lot more whenever it's a threat to human life, as you can imagine. So natural hazards are processes that could be caused by internal forces on the earth or external forces on the surface of the earth. So earthquakes, tsunamis, volcanic eruptions, landslides, mass wasting, climate change, we'll talk a little bit more about because there are a lot at the end of the semester, because there's a lot more that goes into it than just internal forcings from plate tectonics or pure geological forces and features. So we'll get into that. That's more of the human element. Same with landslides and mass wasting. There's a big human element in that as well. So they can also be caused by fully external forces from solar energy from the sun. Flooding is often caused by solar energy. Severe storms and erosion. Again, climate change can also, parts of it can also be caused from external energy, which we'll get more into. Some of it we have no control over at all. So watch this about an asteroid that we had come near Earth a little while ago.
I can't hear it.
You can't hear it? Yeah, it's probably okay. You can't hear it. Basically, in 2019, on July 26th, we had an asteroid come very, very close to Earth. It was about, I can't remember how many meters, probably like 10 meters wide. It was similar to the one that fell in Russia a while ago, if any of you remember that one, which wasn't catastrophic, but it was pretty damaging to the area. It had a severe shock wave that caused a lot of broken glass. A lot of people were taken to the hospital because they saw this brilliant white light that came to Earth. So they went to the window to look at it, and then the shock wave hit as they came to the window. So they just had broken glass everywhere. But the thing was, scientists didn't find this until it was like already passing the moon, which is really crazy. So there are some parts of natural hazards that we don't really have control over, or any way of really mitigating or monitoring. So a lot of these natural hazards that we study are often interrelated and they affect each other. So if, as Ortiz mentioned earlier, Hurricane Sandy caused a lot of flooding in New Jersey and New York. Flooding can also cause landslides with increased slope instability. If you imagine wetting a hill slope that's just been dry, it just gives it kind of a surface that can slide, so that's going to create a lot of landslides. Earthquakes can also cause landslides. Landslides can even cause volcanic eruptions. If you have, for example, Mount St. Helens, there was a small landslide on Mount St. Helens that basically all this weight was lifted off of this volcano, and because of that weight, the pressures inside were able to release, which created a really violent eruption. Climate change can influence hurricanes. If you think about how hurricanes work, the fuel for hurricanes is warm, wet water. So if you have a climate where the water is significantly warmer for a longer period of time, you're going to have an increased amount of larger scale hurricanes, Category 5 hurricanes. So that's another way of looking at it. So a lot of this is governed by location, the type of hazard, and the intensity of the hazard. So where do most of these occur? So this is a map of the lower 48. Well, Alaska and Hawaii are on there at the bottom, but so this is the intensity of floods and number of floods that we have in America since 2008. As you can see, there's a lot running down the Mississippi River, right through Missouri and Arkansas, Western Tennessee, obviously the state of Mississippi, Louisiana. We also have a lot, if you look at New Jersey and Pennsylvania, and Delaware as well. We have a lot of flooding there. Also a lot in the Southwest, surprisingly. Most of that is due to they get all of their rain at once rather than not in a sustained period like we do in the humid Northeast. So they get a lot of it at once, and that just creates a lot of flash floods. This is earthquakes and volcanoes. As you can see, we get a lot of earthquakes along the west coast of America. It's part of what's known as the Pacific Ring of Fire. We get a lot of volcanoes there because it's a plate boundary. So we have a lot in Alaska, a whole lot in the Pacific Northwest, and definitely a lot along the faults in San Francisco, Los Angeles area, and California. Take a look at Oklahoma City as well. There's a lot in that area too, in terms of earthquakes. There's a lot. So a lot of these are really built upon location, and they're really localized to a certain area, certain geologic hazards. So this is going to be our second poll. Which of the following U.S. cities is most at risk for a catastrophic tsunami? Based on that previous image. Hold on, let me find this. There we go. So what do you guys think has the biggest risk for tsunami?
For some reason, I can't see the poll anymore. Which,
Yeah, I
Oh, you
can't
can't?
see.
yeah, maybe try posting it again or something.
Let me see. Well, it's not letting me post it again.
You can just type in chat, I guess.
Yeah, sure.
Can you say the options again? It was San Francisco.
Yeah,
Oklahoma.
Newark, Portland, Oregon, Oklahoma City, San Francisco, Memphis.
Sorry, can you restate the question again?
Which of the following cities is most at risk for a catastrophic tsunami? All right. So a lot of you think San Francisco. Some of you think Portland. I would say both of those are pretty good answers. I would say Portland more than San Francisco, mainly because a lot of San Francisco's earthquakes are more inland, whereas Portland's earthquakes are more near the ocean. There's a lot of different plate boundaries at work there. So I think that would be a good example. So Portland and San Francisco, just based on their location purely. So here we go. Alrighty, where is it? There it is. Thank you guys for your patience.
No problem.
There we go. So a lot of these activities can also be influenced by human activity. As you can imagine, humans have engineered and built a lot of things on top of the surface of the earth, and we don't necessarily always do the best job of planning out how to build those things. For example, this is the picture on the left is where is that? I think that's in Maine, actually. Yep. Yeah, so that's in Maine. This entire roadway just collapsed because they built it right along all on these unconsolidated sediments. So continuous wave action just ate away at it until it collapsed. So as you can imagine, that was a really expensive loss. Flooding as well. Whenever we build things, specifically roads, parking lots, we're creating a surface that water can't infiltrate. So it will flow or stay or preferentially flow into rivers or something. And sometimes we're not very good at directing that water, as you can imagine. So how about for this one, let's just type it into the chat. Which of the following cities experiences earthquakes the most frequently? Newark, same ones as before. Newark, Portland, Oklahoma City, San Fran, Memphis. All right, San Fran seems to be the top. Some of you think Portland, some of you think Oklahoma City. All right, the answer might surprise you. It is Oklahoma City. So who can tell me why we have earthquakes in Oklahoma City? What's going on there?
I'm not entirely sure, but I remember on the map it said something about like an oil fracking operation or something hit like something, and that caused like small amounts of earthquakes to happen like pretty frequently.
That's exactly right. So Oklahoma City is, and the surrounding area, it's a huge oil and gas field. So there's a lot of fracking. And the way, if you're not familiar with what fracking really is, it's oil is found in these very thin layers. So the way to extract as much oil as possible is injecting fluids that will break apart these rocks and hold them open with grains of sand, and then pump all of that oil out. Once all that oil is out, anything that you use to extract any of the cutting fluids, you inject back into the earth, right into the void space. So essentially what you're doing is you're injecting fluids into an area that hasn't been geologically active for millions of years. So you've essentially lubricated that surface, so all the rocks just start sliding around. Now, it does increase a lot of it causes a lot of earthquakes, yes. But are they particularly damaging? No. So this is a hazard, but I wouldn't say it's an incredibly serious hazard. The types of earthquakes that they're getting in Oklahoma are probably a 1, maybe a 2 on the Richter scale. They have a whole bunch of them, but just to put it into perspective, if you were standing, think of where you're standing right now. If a magnitude 3 earthquake happened right underneath your feet, you might feel it. If it was a magnitude 3.5, it would feel like you're standing on I-95 and a tractor trailer drives by. That's the type of shaking we're talking about, not the kind that's going to collapse a building. In San Francisco, on the other hand, those are at a lot higher magnitudes, 5, 6. Those are the types that could bring a building down if it's not engineered properly. So those ones are probably a lot more damaging. Those don't happen as frequently though. So frequency doesn't always indicate how damaging, potentially dangerous specific natural hazard could be for an area. It's more based on the intensity of the natural hazard. So some hazards are beyond what we can really prevent, what we can even control. So if any of you are unfamiliar, the Chesapeake Bay was mainly formed due to a large impact crater that happened a couple 100,000 years ago. Basically, we only know that because of drilling in the area. If you ever drive down south through Delaware, Maryland, you'll see a lot of farms. Those farms get their water from aquifers sitting on top of the bedrock and deep underground. This impact crater is affecting those groundwater aquifers. It creates all these slumping chunks of rock that we see on the image to the right. Basically, it blocks off certain access to water from certain wells, so new wells have to be drilled. This is really something that we have no way of mitigating because this is a huge impact crater that it would be incredibly difficult and incredibly expensive to try to even dig it out and like stabilize things. So some things are just beyond what we can even not comprehend, but wrap our minds around how to tackle the problem. So this is an example of volcanic eruptions that we can't really control. This is White Island in 2019. This was a pretty big eruption, huge eruption. Huge ash cloud, probably 500 meters tall, spread ash along a huge area, created some landslides that fell into the water, caused a few smaller tsunamis, not too devastating, but still pretty large. As you can imagine, there's a lot of toxic gases in these volcanic ash clouds as well. So sadly, there's not really much we can do about volcanic eruptions. We can monitor them and we can forecast with them, but we can't really stop it, can we? So our understanding of geologic hazards is based on geologic processes, and those processes are classified based on what we can see today. So the concept of uniformitarianism is something that James Hutton in 1750 discovered. He had the idea that the same stuff that we see on Earth today has been happening for hundreds of years and thousands of years and millions of years. So if you, for example, you see a volcano erupt or an earthquake happen, those same things have happened far enough in the past. So if we can understand what's going on in the present, we can also understand what happened in the past. And conversely, if we understand what happened in the past, we can kind of predict and forecast what's going on in the present, in the future. So, for example, if we see modern lava flows, this is from Kilauea, which has been erupting for a while now. Actually, it just recently started erupting again. We can see these lava flows in real time. Once it's solidified, though, we can see this in the geologic record. We can actually map out where these are, and we can see if there was past lava flows in an area, if it would potentially erupt again, or if it's not really a threat that we have to worry about anymore. Same thing with earthquakes. So if we have faulting during an earthquake, you can see that you have this offset in the road now. That's something that we can observe with large-scale earthquakes, where it creates a rift. We can see the same thing in the geologic record in fault systems. So if we have an offset like that you see on the right, we can tell based on that displacement how devastating that earthquake is, how frequently it happened, and how likely it is to happen in the future. So something to keep in mind when it comes to understanding hazards is understanding how risk works. So risk is the probability of the event times the consequences. And there's also things called perceived risk versus actual risk. The best example I can give of the difference between perceived risk and actual risk is think about sea kayaking versus rock climbing. Whenever you're rock climbing, the biggest actual risk that you have is the rope breaking. That's really the only risk that there is. Granted, that's a devastating risk if it happens, but that's the only one. So, but rock climbing is seen as more dangerous than sea kayaking. If you're sea kayaking, you have the risk of, number one, being pulled into a current. Your kayak could sink. You could get hit with a storm. So that's a lower perceived risk, higher actual risk, versus rock climbing, which is a low actual risk, high perceived risk. Probability is also a big factor in associating risk because lower magnitudes have a greater probability. Think of Oklahoma, lower magnitude earthquakes. They have a lot more of them. A higher magnitude event has a lower probability. Think of some of the most devastating earthquakes that we've had. They don't happen very often. But whenever it comes to risk, the most important thing is the consequences. How specifically people, how are people going to be affected? What kind of damage will it do to infrastructure, personal property, things like that. So this is from Dr. Adam Wallace. He's a geochemist with us. He studied at Berkeley. So this is an example that he gives in his classes, which I think is a really good example. What types of risks are people willing to live with? So his house is right next to this huge fault system. These red lines on this image to the right indicate these large fault systems in California, which is where a lot of earthquakes happening. There's two big blocks of rock that are sliding past each other. They get stuck and sometimes they crack and release energy. So that's a high risk living next to a fault system. You might have a high risk of having an earthquake. At the same time, you could benefit from having just an absolutely gorgeous view of the Golden Gate Bridge in your in your house. So it's understanding what people are willing to live with and what risks they're willing to take in terms of which geologic hazard. So acceptable risk, the amount of risk that an individual or group is willing to take. Dr. Adam Wallace was willing to accept the risk of an earthquake in San Francisco to have that beautiful, gorgeous view from his house. At the same time, his house was probably built to earthquake standards because it's in San Francisco. They have a lot of earthquakes, so they know how to plan for it. So whenever we study hazards, we want to study the when did things occur, and what time, how long it happened. So we can understand that by looking at human history. I'm sure all of you have heard of the Mount Vesuvius eruption from Pompeii, which was, as you can imagine, pretty devastating, but it left a very good record. We know exactly when it happened and how it happened. We also want to look at the landscape. This is where geomorphology comes in, looking at landscapes and seeing what looks like it happened in the past. So if you look at this area here on this image, the white on that hill slope is exposed rock, whereas the red is vegetation. So as you can imagine, this probably slumped at some point. There's that big like mass at the bottom of it that probably came from that big white part up top of this hill slope. So this is in California. Coastal California has a lot of landslides. So you can imagine that if this has happened in the past, it will probably happen again, which it did 3 years later. It slumped and it overran a few houses in this small coastal town. So looking at the landscape can give us a really good idea of what has happened in the past and what will potentially happen in the future. If we look at the geologic record, most geologic hazards leave behind an imprint. For example, Pinatubo had these huge ash clouds, miles and miles high. All that ash eventually spreads out and settles down onto the ground. For example, houses in the Philippines had to like dig it out like snow today, just because of how much ash was falling on their houses and their driveways. We can see those types of eruptions happening in the geologic record. So this is what's known as the Bishop Tuff. This is also in California. It's also found in Arizona, New Mexico, Nevada, like very, very wide area that this covers. So, and just for scale, that man in the corner is about 6 feet tall. These are huge, huge ash deposits. So based on the spread and the height of these ash deposits, we're able to conclude where this eruption occurred from and when it happened and how severe it was. So this specific eruption that caused the Bishop Tuff, which we see everywhere, came from Mammoth Mountain. If any of you are familiar, it's a really big ski resort in California. It used to be very, very active. It's not anymore, luckily, but these types of things can help us predict how this could happen in the future. So a natural hazard versus a natural disaster is based on the time duration, the area, and it has to meet a certain criteria: the number of people killed, how many people does it adversely affect, and that could be from destruction of home or property, loss of economic opportunity, was a state of emergency declared, did people need to assist from neighboring countries, things like that. So the biggest thing is just the involvement of people. As you can imagine, the example, if a tree falls in the forest and no one's around to hear it, doesn't make a noise. Same thing as if a tree falls in the forest and it falls on top of somebody, that means it's a problem. If a tree falls in the forest and nobody's around, it doesn't really matter, does it? So whenever we talk about natural hazards and disasters, we care about the human element because that's what we care about the most, of course. So if you look at this graph, we have an increase in natural disasters from 1960 to 2010. We've had a lot of deaths and a lot of financial losses. Why do you think there's a growing trend in natural disasters? Does anyone have an answer for that? Why is there an increase in natural disasters?
I think it's climate change. Climate change causes more natural disasters to happen.
Okay, climate change could exacerbate that. What's something else that could, when talking about the human elements, what's something that could increase the number of natural disasters?
There's more people all over the earth.
Very good. That's exactly right. So we have more people living in more places. So more people equals increased exposure to hazards. So if you imagine in 1830, were a lot of people experiencing flooding in, say, San Francisco or Los Angeles? No, not a lot of people were living there in 1830. But more and more people live there now, so they feel things like earthquakes, flooding, storms more frequently. And more people means more people reporting, more people saying oh, I felt this earthquake, because now there are people there. So the increase in population has led to that increase in natural disasters. There may have been the same amount for the past 70 years, but because more people live there, now it's a problem for the human population. So that's something important to keep in mind. So urbanization is also a big deal when it comes to creating the potential for catastrophe. A lot of poor land use practices are based on where we build. For example, floodplains. Floodplains are those really nice, long, flat areas that go right next to rivers. People like building on them because they're already nice and flat, so you don't have to bulldoze, you don't have to level anything out before you start building. It makes building things really easy whenever things are already flat. The problem is, the reason it's called a floodplain is because flooding happens there. So as you can imagine, staying in low-lying developed areas, this is Houston after Hurricane Harvey, they experienced a lot of flooding in the floodplain. So if we build in areas that are prone to these types of events, we're going to experience them a lot more. So the reason we care so much about studying these is because, as I've said before, we're going to be able to forecast and monitor and understand how these events occur, why they occur, where they occur, and how we can plan for that. So the really important signal is, are there any precursor events that event is going to occur? So for example, like something we didn't know with volcanic eruptions, that we do know now, is that earthquakes are frequently attributed to, there's a high frequency of earthquakes around a volcano right before an eruption. If we're able to sense those earthquakes, that means we can probably get enough warning out to people that live nearby that an eruption is imminent. Same thing with tsunamis. For example, the tsunami that hit Japan in 2016? No, 13. Oh man, memory's not what it used to be. But that same tsunami, they had about 3 hours of warning time because we knew about that seismic event that caused the tsunami before the tsunami even reached the shore. So the ability to understand these, it enables us to forecast and allow enough warning for more people to get out. So hazard forecasting is something that we as scientists do a lot because it's beneficial to the public. We call it forecasting, not predictions. Predictions gives the idea that we're looking into a crystal ball and just pulling something out. Forecasting is there's data there. We're looking at data. We're creating, we're putting things together based on what we see in the actual data that we collect. So once we collect the data, we're able to review it. And once we're able to forecast how things work, we send that to public officials and they're able to warn the public. It's a slow system sometimes, but it's the best system we have right now. So why do we want to study these? Well, number one, to become more scientifically literate. Everyone should strive to be a little more scientifically literate, but these things are always going to happen. So they'll also become more severe. So why not just understand how they work and understand better ways of protecting human populations. We also have the effects of climate change that we have to worry about as well. So in the past, we understood more natural hazards and how they worked under normal circumstances. Now we've added the extra issue of climate change on top of that. How is that going to exacerbate natural hazards, certain natural hazards? And understanding more about them can obviously save lives. That's the really important part of studying these. So for example, and this will be the last example of the day. We have two cities versus earthquakes. Haiti in 2010 and Port-au-Prince had a magnitude 7 earthquake. Huge number of deaths. 100,000 was in, I think, the first day of the earthquake. Something also that happens with earthquakes is if you think about fire suppression, if you have earthquakes that create cracks in buildings, they can also create cracks in water pipes. So a lot of damage and deaths that come from earthquakes is from fires that can't be put out. So this is an incredibly devastating earthquake. Haiti still hasn't fully recovered from this particular event. It caused $14 billion in losses. It didn't impact infrastructure a lot, but the biggest problem was the housing situation. There was a lot of impoverished communities that didn't have safe building codes, and because they didn't have safe building codes, a large earthquake just shook the buildings apart. So this specific earthquake was really, really devastating. Now come to San Francisco, a very similar earthquake, magnitude 6.9. It's the richest country in the Western Hemisphere, and they have a lot of earthquake-proof infrastructure in place already. So San Francisco has already recovered from this earthquake in 1989. It caused $50 billion in losses, but overall that was comped pretty well by tax revenue. It only caused 63 deaths. It also had a lower population density and a lot of improved warning systems. San Francisco has been living with earthquakes since the 1900s, so they have a lot of preparedness plans in place. So this is just an example of what science can do in forecasting, in planning, and prevention. So this is what we're going to study in this course, and hopefully as we talk through each of these natural disasters and each of these hazards, you'll understand a little bit more about why it's important. So that's all I have for today. Wanted to keep it kind of short for the introduction. Before I go, are there any lingering questions on the course itself, on how it's structured, on anything that I can do to help you guys succeed?
This is more of a personal question, but I forgot to sign up for one of the labs. Is it possible for me to still sign up for one of them?
I believe so.
I'm pretty sure the date's until the end of the day, right?
Yeah,
Okay.
I'm pretty sure if you go on to log on to SIS, they'll still allow you to register. If you do have any issues with registering, let me know and I'll put you in touch with our department chair who can probably schedule that for you. No problem.
Okay. Thank you. I really appreciate that.
My pleasure. Any other questions from anyone else?
I kind of do. I was wondering if Proctor U will take into account, like, with working with you about like DSS and like extra time and stuff like that. Proctor U.
Yeah, that's an excellent question. I'm gonna have to get back to you on that because I'm not very familiar with Proctor U yet. So I'm pretty sure it's when you schedule like an appointment with it and like you're given a certain time period. So we'll cross that bridge when we get there. I have a feeling we'll still be in person, so we'll see. But I'll get back to you on that and I'll get to a little more information about that. But thank you for letting me know.
Thank you.
Anyone else? See some in the chat. Okay, well, if that's everything, it was nice to meet you all. Hopefully this will be a good course. This is my first time teaching online, so I'm sure you guys have a lot more experience with I do than when it comes to online courses. So have a great day, and I'll see you guys same time tomorrow.
Thank you.
Thank
Thank
you.
you.
Thank you.
Alright. I have a quick question.
Thank you.
Does someone have a quick question?
Yeah, I'm just wondering how do I participate in the lab sections since it's all online now? And I
Okay,
don't see anything on Canvas or emailing it.
So for the lab sections, I'm gonna have a meeting today with one of our TAs to talk about how we're going to handle this. You're not gonna have lab today or tomorrow, but starting Wednesday, they're going to hold lab. Are you also in section 10?
I'm not sure. Let me check.
Professor, I know you said that you're going to post a video of the class session. Are you also going to be posting slides?
Yes.
Okay.
Yeah, that'll be in the two different folders: recordings and then lecture slides on Canvas.
Okay. Thank you very much, sir. Have a good one.
Thanks, you too.
Yes, I am. I am on the section 110.
Section 10. Okay. Yeah, I'll post something on Canvas about how lab will work with that.
So I just, regularly check my email and Canvas.
Yeah, that'll be the best bet. Just because we're supposed to have 3 sections. 2 of them are covered at the moment. Apparently, we still have one that we haven't found a TA for. So,
Gotcha.
so we may have to scramble to get that together. So I'm gonna send some emails. I'll post something on Canvas about that then.
All right, thank you.
Thank you.